So hello guys, I'm on this side and today we are gonna study about Lex and Yak programming. Like how do they work together? How are they used for compilers, for interpreters, and for other different domains? So we'll start with what their definitions. Lex and Yak are powerful tools for creating lexical analyzers and parsers for programming languages or other formal grammars. They're commonly used in the process of building compilers, interpreters, and other language processing applications. These tools are especially popular in the domain of compiler construction, where they help in transforming source code into executable or other forms of output. So here is a basic brief of Lex and Yak. Lex is as a type of lexical analysis generator that takes a set of regular expression as an input and generates C code for a lexical analyzer based on these expressions. A lexical analyzer, also known as lexer or scanner, is responsible for breaking down the source code into a sequence of tokens. These tokens can be different keywords, identifiers, consonants, or operator. So as you can see, this is the symbol. This is the symbol under which the regular expressions and their actions are given in the C code, and then after that it generates a C code that performs the pattern matching and recognition based certain things. Yak is a parser generator that takes formal grammar specification as input and generates C code for the parser based on this grammar. It is responsible for understanding the structure of the source code and verifying whether it confirms the rules specified by the grammar. So, whatever the code is given and whatever the grammar, either its regular expression or its context free grammar that is specified in the code, it checks that it confirms and verifies that the rules which are given in the grammar is somewhat related or correlated to the code given. So, with the extension, this contains the formal grammar rules and associated actions to be executed when a rule is recognized by the input. So, these both work in a coordinated manner. Lex scans the source code and converts it into a sequence of tokens, and Yak processes these tokens based on the grammar rules to construct the abstract syntax tree. So here is a typical basic workflow. So Lex specification is given in .l, defining regular expressions and various different tokens. Then the Lex file is which is given on the specification file. It is then then it is generated for a C code for the Lexer. Then a Yak specification file with the extension .y that defines all the formal grammar rules and actions for all those grammars to build the abstract syntax tree. Then Yak file is run based on the specification file to generate the required C code, C language code, and these two combine generate lexer and parser code with the rest of the compiler interpreter code to create a complete language processing application. So overall it provides a robust and efficient way to implement language processors, making the task of building compilers and interpreters more manageable and less error prone. So working these both together makes it easier for the coder, for the developer, to easily pattern match, to easily check all the rules, to easily generate a C code which is free from all the errors, from all the syntactical errors, from all the logical errors, and generates a great and efficient code for the regular expression and for the context free grammar to be proved right. See, if you define a regular expression, if you define a context free grammar based on Lex and Yak, so you have to check whether it's right or wrong, whether there is any, syntactical errors, or you have missed some symbols, or you have done the basic action required according to with it. So, whatever I've explained you regarding Lex and Yak, we're gonna study it using a code. So this is the basic question. Yak program to evaluate arithmetic expression involving operators. So here you see, when it's about Yak program, Lex has to be there for the basic regular expression to exist. So in this program, we have to check uh, the validity of an arithmetic expression which contains all these four different given types of basic operators. So here comes the definition section where we define uh, all those modules and whatever we're gonna use in our program. Here comes the basic rule section where we define all those regular expressions required for pattern matching. As you can see, when it's 0 to 9, it checks if it's a numeric digit, it checks and it returns a value num. Then it checks for the operator if there consists an operator. Then it consists, then it checks whether there are any brackets. As you can see in this code over here, it checks for an closing bracket, it checks for an opening bracket, and it checks for a dot too. It checks for a new line character too. When it comes to React, again it contains a definition section where two modules known as stdio and stdlib are defined. Then you come to the next section where the priority, like over here, the priority of these are considered like the priority in which the operators needs to be evaluated. Then comes the definition section. Here it checks what should be done. As you can see, the input would be an expression. Obviously, if it's an expression, what it will print and what how will it exit. So the first expression consists of the plus operator. If there is a plus operator, what would be the output? As you can see, dollar is considered as the output, and $1 and $3 are considered as two inputs to the basic arithmetic expression or arithmetic function. Then comes same for the negative sign, comes same for the multiplicate sign, and then when it's divide, so there is a logical error which can arouse here, that if the denominator turns out to be 0, then what it would do. So if the denominator turns out to be 0, it would basically print divide by 0 error, because any number can't be divided by 0. Else, if the denominator is not 0, whether it can be greater than numerator or less than numerator, but if it's not 0, it will basically print out what will be the output of the arithmetic expression. Okay, and also if there are brackets too, if there are brackets too, then also it will print what would be printed there. And if there is a number given instead of those alphabets a b c d, if there is number given, then it would what it would print. So this comes the basic rule section, which consists of context free grammar according to the yak program. So next comes the definitions section, which contains the basic C code which is required in the given program. So as you can see, we have made a function called error. It is basically used when if there is an error, what would it print? If we have given a not so valid arithmetic expression, or there has been an error while inputting, while evaluating. And then comes the main function. It will take an it is basically used for inputting. The main function is basically used for inputting, printing, and taking care of the end results. So as you can see, I have put up all these. There are different basic commands used. So for basically we have to first we have to use for lex program. We have to consider, we have named this 1b dot l, then vi 1b dot y, and then we have to go through two different type of uh, I guess like commands to run it. 1b dot l, then yak minus d 1b dot y. As you can see, these are the commands to basic output functions. And then maybe the biggest code, I guess, what was it? I guess it was cc lex dot yy dot c y dot tab dot c minus ll. These are the commands, and then alpha obviously a dot out. So this is the command which is used to run a yak program, which consists of lex program 2 over here. So I guess that's it for the video. I've explained you the basics of yak and lex. I hope this was informative. I hope this was very useful, and I was able to cover most of the points. And I tried to keep it not very detailed, not very brief, but in between where it was detailed on the part that was important. So guys, thank you for watching the video. Do like and subscribe, and leave a comment if you like any part of it. Thank you so much.